Here's a question I received this morning. I have doubt in polar representation of complex numbers. In case of finding out the value of the angle, should the signs of b over a be considered or not? Individual signs of a and b. Please help me with an example. So here's the example that I chose. And the answer is yes, the signs always need to be considered, but if you know what you're doing in the actual computation itself, you don't need to consider the signs. So what I would do is always draw a picture or think a picture of the point that represents the complex number in the complex plane. And the complex number I chose was -4 plus 5i. And I drew this picture to represent the point. The point is right here. This is the real axis. This is the imaginary axis. And what we need to find is r and theta. And notice that the point is in the second quadrant. So theta, we want to find this theta right here. So I know you're only asking about the angle, but I'm going to go ahead and do the computation for r as well. To find r, we just would think of this as a right triangle. This is 4 units long. One leg is 4 units long, the other leg is 5 units long. So the hypotenuse of this right triangle would be the sum of the square root of the sum of the squares of the legs. So 5 squared is 25, -4 squared is 16, 25 and 16 is 41. So r is the square root of 41. And I'll go ahead and write that. R equals the square root of 41. And then for theta, in this case, theta, we're going to find the reference angle, which will be this angle here, or the measure of this angle here, the reference angle. Actually, the reference angle is always a positive angle. So the measure of reference angle is always positive. So we're actually going to be finding this angle here in the first quadrant. Reference angles are always between 0 and 90 degrees, or 0 and pi over 2. And they're always the measure of the angle between the terminal side of the original angle and the x-axis, or in this case, the real axis. So to find that, I'm just going to do theta equals arctan of 5 over -4. Now, the range of the inverse trig functions is restricted. The range of arctan is between 90 and -90. The range of arcsine is between 90 and -90. And the range of arccosine is between 0 and 180. So we're using arctan. We're taking the arctan of a negative number. So we're going to get a angle in the fourth quadrant, or an angle between 0 and -90. So I've got my calculator here. We know that 5 divided by -4 is -1.25. So I've got it in degrees here. So I'm just going to do 1.25 negative plus or minus. So -1.25 and arc tangent. So we see that that's -51.34 degrees. The reference angle for that is just 51.34 degrees. So we want to find this angle here. So we know that from the positive horizontal axis to the negative horizontal axis, that's 180 degrees. So since this is equal to, oh, I need to see that again, -51.43 degrees. So -51 I think I said 4, 3, but I think I saw 3, 4. So 3, 4 degrees. So that's this angle right here. And the reference angle is, so I'm going to represent the reference angle by theta sub r. So theta reference is equal to 51.34 degrees. Remember, the reference angle is always a positive angle, and it's always between 0 and 90 degrees, or between 0 and pi over 2. So in this problem, finding the polar representation of this complex number, theta is going to be equal to 180 minus 51.34. And I think that's equal to 128.66. Yeah, 128.66. 128.66 degrees. So a shortcut way of writing complex numbers in polar coordinates is r cis theta. So this is r. This means r times the quantity cosine theta plus I sine theta. So to finish up this problem, we have z equals the square root of 41 cis 128.66. And this means that r is square root of 41, and theta in both cases is 128.66 degrees. So I hope that helps. It really just boils down to drawing the picture, figuring out the length of the hypotenuse, and then figuring out what r is, and then just doing it. So I hope this answers your question. Kirthana, I think was your name. So I hope this answers your question, Kirthana. Thanks for the question. If there's anything that doesn't make sense in my presentation, please don't hesitate to email me and ask questions, or you can even call me and ask questions. And if anybody else watching this has questions, the same goes for you guys too. So hope this makes sense. Have a great day, and I will talk to you next time.